Good evening, everyone. This is Mabel Benvenuti, and tonight we're going to be doing a lesson on adding and subtracting fractions. And today we're going to actually be doing it with two different models. So to begin with, we're going to be doing addition. So today we're going to be working with this problem, and I apologize if it's not really visible. So we're going to be doing 6/10 plus 3/10. Okay, so let's begin. So I do have my problem written here, and I know it can be a little bit fuzzy, but I do have 6/10 plus 3/10. Okay? So for us to be able to visualize the problem, this is what we're gonna do. We're gonna do a little rod on the side. 6, 7, 8, 9, 10. This is to illustrate our first problem, our 6/10. Right here. And then our 3/10. We're going to do the exact same thing. Just so we have a visual and we are able to see the problem in a more clear way than just to have it written out. Okay? So we do have our two rods here, which demonstrate the problem. Let me bring it closer. So as you can see right there. Okay, so for us to identify what it is that we're trying to do, we have to make it simpler for you to see. To identify the 6/10 on our rod, we are going to shade in 6 of our little squares. So we're going to go 1, 2, 3, 4, 5, 6. So that right there visualizes our 6/10. Okay, and then for our next one, our 3/10, we're going to do the same exact thing. So we're going to shade in 1, 2, and 3. Okay. So now remember, this is an addition problem. So the way that we figure it out is we count. How many shaded areas do we have? So we count. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that means that our answer is 9/10. Did everybody understand how we got that problem? Now, you may be wondering why it's tenths. Well, it's because the denominator, which is the bottom number right here, is the same. So it will remain the same. That's not going to change. Okay? But the bottom number is not the same. So that's why we have to count our little rods. The ones that are shaded, it's 9. So that gives us our 9/10. Okay? So that's how you can utilize this model to figure out these kinds of problems. Any questions? Okay, great. Now we're gonna go to our subtraction. I do apologize. Give me 1 second. Now for our subtraction model, we're going to be using the circular. We're going to be doing this as a subtraction of pizza pieces. So we're going to pretend this is actually our pizza. Okay? So this is a pizza. Yummy. Okay. So where is our pizza? So for our pizza model, it's very simple. So of course, we have to count how many pieces of pizza it is. Now, remember, we're going to be using the whole number of the pizza, which is all of this, as our denominator. So we count. So it's 1, 2, 3, 4, 5, 6, 7, 8. 8. So we know that 8, it's our denominator. Okay, and we're going to use, so it's going to be the 8 pieces of pizza minus 5. So we need to figure out how many pieces of pizza are left. So say per se you and your friends divided, all of in between you and your friends, you ate 5 pieces. So the easiest way to do would be to shade in the pieces. So, like I mentioned in the problem, we have 8 pieces of pizza, which is our whole pizza. But we need to subtract 5 pieces because those 5 pieces are what has already been eaten. So, again, we are going to shade in those pieces that have already been eaten. So we go 1, 2, 3, 4, and 5. So there we have our 5 pieces of pizza shaded because those are the 5 that were already eaten. So how many pieces have not been shaded in? We count. 1, 2, 3. So the answer to our problem would be 3 3/8. And again, if you're wondering why, well, it's because 8 minus 5 does equal 3. And we don't do anything because with the denominators because they are the same. So the denominator and the answer will also be the same. So I hope that this model helps you understand a little bit about addition and subtraction regarding fractions. And so I hope that gives you a little bit more of an example and it makes it easier for you. Okay, so I appreciate you watching this video. Thank you so much.